Hello, and thanks for using TickBoom. For this question, a student has sent me through question 16 part A, which asks us to consider the graph of the function y equals e to the x, and then by considering areas show that if n is a positive integer, then 1 on n is less than e to the 1 on n minus 1, which that is less than e to the 1 on n on n. And then using that, show that 1001 on 1000 is less than e to the 1 on 1000, which is less than 1000 on 99, and we can't use the calculator. Now, before I jump into this, I've got to say, without a doubt, this is the hardest question I've had sent through to me so far. I really had to rack my brain to kind of get to what I think is a workable solution, but I've had to use a few interesting techniques, I'll call them. So take a look through, see what you think, and if you think I've done something wrong or if you think there's a better way, please feel free to share in the comments, because this one really did have me a little bit stumped, but I think I've got to a solution that would hopefully get you the marks on a question like this. So we'll start with part 1, and that is asking us to show that 1 on n is less than e to the 1 on n minus 1, which is less than e to the 1 on n. And we're kind of told in the question, use charts basically to demonstrate this. And I should say we're told that n is a positive integer. We know we can't divide by 0, so effectively n is going to be greater than 0 in an integer. So that's what we're dealing with. Now, to help simplify things, I guess, when it comes to charting, what I think a good first step is to say, let's let x equal to 1 on n. Because if we do that, then what we're really dealing with is x less than e to the x minus 1 less than x e to the x. And when it comes to charting those things is a little bit, I guess, more palatable. So really, there's 3 things that I think if we can chart, we can then demonstrate what we're dealing with here. We want to chart, first of all, y is equal to x, this item here. Then we want to chart y is equal to e to the x minus 1. And then we want to chart y is equal to x e to the x. And if we can see that on the chart, where these lines end up follow this inequality, then effectively we can say that we're demonstrating it using areas, I guess. So what I'll do is I'll draw up an axis, and we'll take a look at what this chart might look like. So 1, 2, 3, 4, 5, 6. 1, 2, 3. Won't need to go too far negative given what we're dealing with. Alright, so I'll just get this axis set up. We'll have our x and y and 0. Go up to 5. So 1, 2, 3, 4, 5. Negative 1, negative 2, negative 3, negative 4, negative 5. 1, 2, 3, 4, 5. Negative 1, negative 2. Alright, so there's our axis. What I'll do is I might use different colours for each of these charts, but let's start with our easy one, y is equal to x. So at every point, whatever x is, we also get y. So that's a very easy chart to plot. Let's get my ruler. that's y is equal to x. So the next one we'll do is e to the x minus 1. So I might do that in, maybe I'll do that in black. For a chart like this, I mean, I know e to the x will kind of follow this shape. So when you subtract 1, you'll kind of just be shifting it down by 1. So you could do it that quickly, but just in case you didn't know that, you weren't familiar, then like with all charting, you can just get out your calculator and start to throw things in. So when x is 0, we get 0. So e to the 0, which is 1, minus 1 is 0. So at x is 0, y will be 0 for this second chart. When x is 1, we get e to the 1 minus 1, so the kind of 1.7. So let's just call it there. When e is 2, we'll get, when x is 2, we'll get e to the 2 minus 1, so about 6.4, which already is kind of off the chart, so I'll just put a point up here. When we're dealing with the negatives, so e to the negative 1 minus 1 give us about 0.6. Negative 2, e to the negative 2 minus 1 is about minus 0.8. And I know that it's going to be asymptotic at negative 1, so rather than spending too much time, I'll just draw that chart. Okay, so that is y is equal to e to the x minus 1. Now in my last colour, I'll do y is x e to the x. And I'll use a similar technique. You know, e to the 0 is 1 times 0 is 0. So we're at 0 here. All three charts go through the origin. When x is 1, we'll go e to the 1 times 1 is 2.7. About there. When x is 2, so e to the 2 times 2 is 14, so even further off the chart. Negative 1, so if I go e to the negative 1 times negative 1, I get minus 0.3, so probably about there. E to the negative 2 times negative 2 is minus 0.27, so a little bit higher. Negative 3, e to negative 3 times negative 3 is minus 0.14. And with this chart you get this interesting thing where it gets asymptotic to 0, then kind of comes out a little, and then comes back up and is much steeper than just e to the x minus 1. So that's y is equal to x e to the x. And then we have our three charts. Now, just generally we can see that for all the values of x I've plotted, the x e to the x always has y values higher than e to the x minus 1, which always has y values higher than x. Now the only exception there is at 0 where they're equal. And notice there aren't any equal to signs here. But that doesn't need to concern us, because if we have n greater than 0 and I've let x is equal to 1 on n, then that must mean that we're dealing with x between 0 and 1 at the end of the day. So really what I'm most concerned with is whether between 1 and 0, so all this area here, do my charts satisfy this inequality? And we can see that between those points they do. So at this point we could say, maybe however you want to word it, from the chart, we can see that x is less than e to the x minus 1, which is less than x e to the x. Therefore, and I'll say for x between 0 and 1, Therefore, if I replace the 1 on n back in, 1 on n is less than e to the 1 on n minus 1, which is less than e to the 1 on n for n greater than 0 integer. So that's how I tackle part 1 of this question. Ultimately, it turned out not to be too bad in terms of the charting, fairly simple. And the question is really guiding us here because it's kind of saying use charts, think of the generic chart e to the x and then use that knowledge to kind of solve this inequality, because trying to do that with pure algebra I think would be very hard. But what it's done now is it's set us up for part 2. So for part 2 I might just come over the page. Because for part 2 it's asking us to show that 1001 on 1000 is less than e to the 1 on 1000, which is less than 1000 on 999, but with no calculator. Because obviously this would be very easy with a calculator, you just key them all in. But without a calculator, we now need to kind of turn our thinking caps on. One thing I notice is we're kind of effectively dealing with n is equal to 1000, where this first item is n plus 1 on n. This second item is e to the 1 on n. And this third item is n on n minus 1. So really what I want to do is get my result, my inequality from part 1, and see if I can rearrange that to get it into this format, so that then when I substitute n is equal to 1000, I've got my result. So let's start with the result we got before, which was, let me just check, 1 on n is less than e to the 1 on n minus 1, which is less than e to the 1 on n. Alright, so where to begin? I think obvious thing to do is to bring the minus 1 over, because we know we're just dealing with e to the 1 on n by itself. So we'll get 1 on n plus 1 is less than e to the 1 on n is less than e to the 1 on n plus 1. So we've got this bit good. And this gets to n plus 1 on n is less than e to the 1 on n, which is less than e to the 1 on n plus 1. So actually we're looking good here and here. So it's this third bit that we need to really turn our mind to. And this is the bit where it gets difficult, and where if you were sitting in an exam faced with this, my heart would go out to you, because where I got to in how to deal with this, I needed a few little hacks, I guess I'll call them, and whether they jump out to you in an exam is anybody's guess. But here's how I went about it. I'll just kind of do it off to the side here. The first thing that I think helps here is to go back to the very definition of E. And however you might have learned or been introduced to E, hopefully one of the things you learned is that E is equal to the limit as n goes to infinity of 1 plus 1 on n to the n. So that's a definition of E that I think can help us here. And we're dealing with n is equal to 1000, which is not infinity by any stretch, but I think for the purpose of this question, it's high enough to say, well, let's substitute this in. So that's what I'll do as step 1. So I would say e to the 1 on n plus 1 is equal to e, which is 1 plus 1 on n to the n, that to the power of 1 on n divided by n plus 1. And the reason that's helpful is now we can cancel out these exponents, and where we get to is 1 plus 1 on n plus 1. And that gives us n plus 1 on n plus 1. And that gives us n plus 1 on n squared plus 1. And I'll just bring that into n squared plus n plus 1 on n squared. And this is the next part where I kind of got stuck at first. I mean, what do you do here? I need to get this into n on n plus 1. And I think what I'm about to do is valid, but again, feel free to let me know if you think I've done something wrong here. But what I really want to do is subtract 1 from the top and the bottom. And I know that's not going to let me keep my equality because that's not a true thing to do. But I do know that if I subtract 1 from the top and 1 from the bottom, 1 from the numerator and 1 from the denominator, because my numerator is higher than my denominator, subtracting 1 will reduce my numerator, but my denominator reduces by relatively more, which means the whole thing goes up. Which means if I subtract 1 from both sides, the result I get must be bigger than what I've got, which means what I'm dealing with is less than n squared plus n plus 1 minus 1 on n squared minus 1. So I've brought an inequality in, and because I'm dealing with an inequality anyway, if I can put something here that's higher, the inequality still holds true. That's kind of what I'm working with. Now that I've done that, I can go and get rid of those plus 1s, which gives us n squared plus n on n squared minus 1, which gives us n plus 1 on n minus 1, n plus 1. And they can cancel, which gives us n on n minus 1, which is what I was going for. So again, I mean, it's an interesting technique. I think it's valid, but kind of a little hack, a mathematical hack almost. But now what I can do is I can say, therefore, n plus 1 on n is less than e to the 1 on n, which is less than n on n minus 1. So let's put n is equal to 1,000. Therefore, 1,001 on 1,000 is less than e to the 1 on 1,000, which is less than 1,000 on 999, which is what the question asks us to show. And we haven't used the calculator, so I think that deals with the question. As I mentioned at the beginning, definitely not easy. Really quite challenging and very interesting. So thank you to the student who sent this through. I kind of really had to get my thinking cap on here. Hopefully you've been able to follow both parts of that question. The first part, relatively simple, but it's kind of just guiding us to the more difficult part of the question, which requires us to first of all remember the definition of E, which not everyone probably has just lying around in your memory, but it is something worth memorizing and committing to memory because every now and then it comes in handy. And then also this minus 1 on the numerator and denominator and flipping from equality to inequality. I think they're the two main bits that I can't imagine every student would naturally go to, especially in the context of an exam. So hopefully you found that helpful, and tick boom.